Well, looks like we're back again. Welcome to the Tutor Wizard. I'm your host. My name is Tim, and this is Introduction to Statistics lecture number 6 in the series. What we're doing is trying to provide a little extra support for anybody doing spring sessions and taking an Introduction to Statistics course. I'm going to try and stay more or less on schedule with how your professor is going along. With the general coverage is mostly the same from one place to another. I mean, there'll be some things that'll be a little bit different, but not too much. Anyway, what are we doing today? We're going to wrap up contingency tables. We're going to do something a bit more, I wouldn't say mathematical, but certainly a bit more structured. Last time we just had a general introduction, kind of a simple look at it. But today we're going to take a little deeper, maybe not deeper dive, a little bit deeper dive into contingency tables. That's the game. There we go. Okay. Well, no time like the present to get started, I suppose. Let's look at our first slide. So what do we got here? What do we have? So I'm going to check something here for a moment. Just give me a brief moment here. I want to check my layout on this. Oh, that's fine. Okay, we can get rid of that. And we'll go back over here. Yeah, we're all good. Okay. Just making sure my slides are all in order. So what are we doing with this one? So you'll see here is a contingency table describing the distribution of readership for a newspaper. This could be for anything, really. We have males and females. There are different sections, and the values in the table are the observed values. And we want to interpret this and use it for good and not evil, of course, because statistics can be used for evil. Just look at the current state of the world. Anyway, you'll notice here we are asking about the marginal relative frequency for each section. So marginal values are the values that are not inside the table, they're the values on the outside of the table. And then this is what's called the grand total, this one here. So we want to concentrate on these numbers. So for instance then, if we were to look at the sports section, for instance, there are 54 readers of sports from here out of the 192. So this is an exact value. I mean, we could simplify it. It's 27 over 89, but that's kind of boring. That's not 89. What would that be? 96, actually. So let's just turn this into a decimal, because usually when they talk about relative frequency, they want something in a decimal format or a fraction format. So I've got my calculator here. Let me just tap that in. 54 divided by 192 gives us 28.125. Now remember, if they wanted the answer to be in the form of percentage, we would just move the decimal point 1, 2, or times by 100. It doesn't matter which way you do it. I'm not going to give you a hard time about it. I don't think anybody else would either. So this is 28 1/8% of the readership read the sports section. Well, we can do this for all of them. The comics section is going to be pretty close, a little bit smaller, because we've got 48 out of 192. And that is 1/4, or 25%. And this goes on. Now the thing is, we want to check our work, and we do this for all 5 sections. The percentages better add up to 100% or we've made a mistake. So while we're already at 53.125% with just those 2 sections right there, the front page is again smaller. It's at 35 out of 192. And that turns out to be 18.229. Or 18.229%. So there's another percent. Now, that just leaves us the business and the other section. I'll just write this over here, I think. So for business, we had 27 out of 192. And that should be 14 and a sixth, but let's just find out. And 140625. Or 14.0625%. Okay? And finally, we have 28 in the other section. So 28 out of 192. Whoops. My handwriting's terrible. You know that. 28 divided by 192. I don't have a lot of room, so I'm just going to write the percentage. So this is 14.583. Okay, so there's everything. And like I said, if we've done everything correctly, this has to add up to 100%, probably just a little bit less because I truncated all of these. But if I come out to 99.8%, I'm probably going to be pretty happy about that. So let's do that. 28.125 plus 0.25. Whoops. Plus 25. Now we have 18.229. I know there's an ad running. I'm just going to do the monkey work here in the background. And then there's 14.0625 and 14.583. Woohoo! Okay. We did good. So that added up to 99.995%. So a little bit of loss due to truncation, but not a big deal. Okay, so let's review this. What's the key thing to note here? That's the word marginal. The marginal distribution for each section uses the margin values, the red and the green. And we're going to be interested in what percentages they are out of the total percent. And that's pretty straightforward. Let's move on. Let's take another one. Okay, same table, but now what is the conditional relative frequency distribution? And we're interested in the males only. So conditional should send you inside the table. Because there's a condition, and the condition here is males per section. So what do we see? All right, males, 33, right here, for the sports section. Let's look at sports. Okay, so we have 33 males out of 103. So for sports, we have 33. Oh, my screen's bouncing around here a little bit. Let's try and fix that up. 33 out of 103. And we're going to convert that to a decimal as well. 33 divided by 103 is 32%. 3204 with some rounding. There we go. Now, if we wanted to compare that, say, to females, for females, it would have been 21 out of 89. But remember, we're only interested in males, so we just want to focus on the male column. So that's the green highlight will be your numerator, and the total in blue will be your denominator. Let's take a look at comics. So comics is 30 out of 103. So that's got to be really close to the one we just did because, I mean, the numbers are almost exactly the same. That's how you do sniff tests. My number's right, and they should be, because they're very similar to the ones we already know. So this is 0.29126. So this is 29 and 126%. Okay, and we have front page, which we're just going to call FP, because I don't feel like writing that out, being lazy and such. So here we have 15 out of 103. Now we could use a calculator, but we notice that 15 is half of 30, so that means we just need half of whatever that is. Because, you know, this is how you be lazy. Or at least double check. So this is 0.14563. Or 14.563%. I am kind of beating this up because I know the usual lie of the land for the statistics labs. The first statistics lab usually has a fair bit of work on it regarding contingency tables. So that's why we're kind of concentrating on this. Business now is 13. Busyness is 13 out of 103. Well, we can do that. That's 1, 2, 6, 2, 1, which is 12.621%. And that just leaves us one left, and that's other. And that's almost going to be the same because the numbers are almost the same as they tend to be. And it's 11650. So this is 11.65%. Now again, if I've done everything correctly, this and this and this and these should add up to 100% because we're strictly interested in the distribution of the males. So just a quick and dirty eyeball, whatever the hell that really means. Here's 11 and a half. This is 12 and a half. So we're going to call that 24% there. This is 38 and a half. 38, this is going to be 67 and 3/4, and this is 99 and 3/4. So without using a calculator, I'm really close to 100%, and that is what we want. We know we've done it right. Okay, moving on to the females. Didn't want to steal my thunder on the earlier one, that's why I only mentioned the female distribution briefly. So we can do this, same thing. So for the sports section, we have 21 out of 89. Well, that's got to be pretty close to a quarter, I would think. Maybe a little bit less, obviously. But let's see. 21 divided by 89. 2359, 596. So we have 23.596%. So we'll go through these and do them all as well. Comics, 18. Okay, not sure what happened there, but that doesn't look like a C. Let's try again. There we go. So comics are 18 out of 89. And that is 0.20225. Some of the things we could say here is almost half of the female readership reads sports and comics, because if I was to add this and this, I'm at essentially almost 44%. Let's take a look at, and you may get a question like that too. They may say, well, what percentage of female readership look at, say, comics and the front page? Well, we already had done comics, so what is front page? Let's do the front page. We can answer that question. So here is 20 over 89, so that's got to be pretty close to this one. 20 divided by 89 is 22472. Which is 22.472%. So the question I asked is what percentage of females read comics and the front page? Not at the same time, obviously. Comics or the front page would be the proper way to word that. I would take this number and add them together, and that's essentially 42.75%. Good enough. Let's look at business. Now, what is business? 14 out of 89. Now, let's see what we get there. 15,730. Oh, by the way, it's not Comic Sans, I don't believe, for the typing, for the font. Double check what the font is here. Hang on, I'll show you how I do that. Let me finish this here. Sorry. Hi, Sensation. Nice to meet you. 15730, which is 15.73%. Okay, you wanted to know what the font is. Well, let's find out. So I do that, I go over here, and the font is GE Typo Libra. So it's a derivative of something, not entirely sure what. Anyway, that's how we check the font on here. Okay, where was I? Oh, right, we got to finish this thing off. Let's take a look at other. Let's get the right tool selected. So other is 16 out of 89. And that is 0.17978. I almost wrote the wrong number. 17.978%. Okay, so again, if we wanted to check this, just quick and dirty check, instead of using a calculator, we round everything. This is a good way to check numbers without having to get your calculator hand out. So why don't we call this, so this is 15 point something, I don't actually remember what the hell I wrote there. Let's just call that 16%. So we call that one 16, and I call this one 18. So now we're at 34%. And 34, and I just call that 22, so that should give me 56. Then we have another 20 is 76, and then another 23. Well, now we're at 79, which means we're pretty good to go. Oh, interesting question here. Let me get a good look at that question on the chat. It says, does it not bother you when something is statistically unlikely, but represented by large percentages? Can you clarify the large percentage? Because if something is statistically unlikely, there should be a lot of zeros before the first non-zero digit, if we're looking at decimals. Like, how many women do you know that have anything to do with sports in any way? Oh, I see where you're getting at. Yeah. I think what you're looking at as far as this stuff goes, these are just arbitrary numbers. It also depends on the community, too, because in statistics, populations vary. If we were talking about the school newspaper at some college or university that has a strong athletics department, and this is like the case at the university where I work at, the female hockey team, the female rugby team, there's a lot of female involvement, and so you would expect the higher percentage of the readership of the school newspaper would be females interested in sports, because even if you don't play the sport, you're probably interested in how your friends are doing. Now, it kind of depends on the population. Like so much in statistics, it comes down to context. If we were talking about females in a retirement home, the answer is probably not. or if we're talking about females in some, well, I don't want to get into weird things here, but there are communities where, yeah, you would expect the female readership percentage for sports to not be 24%. But then again, there's other communities where you would expect 24% and you wouldn't bat an eyelash at it. So it comes down to the context of the population. And Kayla Astronomy, hello, welcome, welcome. Nice to see some new folks. My intro to stats class, we were taught how stats are manipulated, and she used examples to show how people do it, and it's crazy to see how easy it was. Well, you see, this is why a little bit of numerical literacy goes a long way. The business of statistics, for people who lie with statistics, is all about, to modify a phrase, if you can't blind them with your brilliance, you baffle them with your bullshite. So in other words, if I throw enough numbers up on a screen or on a print page, the average person who's not at least somewhat numerically literate is going to look at that and say, I don't understand that, and go straight to the conclusion which the author wants you to come to, and probably going to go with that. Unless, of course, it's something that they don't agree with, and then they'll just say, well, this is just nonsense. But the point is they tune out, and then you're done. And it's easily called, though people can observe falsehoods. Oh, yes, this is true. You got to be careful about empiricism, though, because what you see in one community, in one population, very rarely generalizes to a larger community. So the caution I would have when I would give for either Kayla or for Sensation Black 1984 is the first question is to ask yourself, what population or what group did these statistics apply to? And once you know that, or once you have an understanding of what you think it should be, then you can hopefully filter the rest of the document in context of that analysis. So to go back to my analogy about a school where there's a very strong athletic, male and female athletic culture, these numbers may not be unusual at all. But would I generalize it to the larger community in the city that I'm in right now? Probably not, because all samples need to be representative of their respective populations. If they're not, it's not valid, or the only validity they would have is to the group of people from which the sample was drawn. And that is basically how things get out of hand. People can observe falsehoods. This is true. As long as you caution yourself that the same mistake, observing a falsehood in one study, doesn't transfer falsehoods to another population. You really should, especially when someone's trying to blow smoke up your rear end, is ask yourself, okay, this is clearly wrong, but how wrong is it, and am I justified to apply that intuitive decision that you've made? Can I apply that to a larger population? But this is one of those things that is very rarely discussed. I don't recall too many people coming out of high school who've picked up on the nuance in statistics of, does the sample represent the population? There's more subtlety to that assessment than the words may initially seem to present. You know what? That's not a bad way to summarize that entire chit chat. Why don't you leave it there? I can come back and chat about that some more in a bit if you want. But yeah, I'm very interested. Kayla Astronomy and Sensation Black, you both are looking into statistics, pardon me. I'd be very curious if you want to contribute a bit more onto the chat about that. I'd be very curious to know your impressions of that first stats course you've taken. It's always interesting to me to talk to people and find out, oh, what did you learn and how did you learn it? How were you taught it? What did you come away picking up from that discussion? Um, just because X, Y, and Z are presented in class doesn't mean every student walks out understanding X, Y, and Z. They may only understand X and Y and a partial understanding of Z. And unless you ask, you may not know. Anyway, carrying on here, new slide, same group of numbers. What is the conditional relative frequency distribution for gender? So male and female who read the front page first. Okay, so you'll notice I've highlighted the row front page, and what we're interested in is the male and female distribution. So you'll notice there are 35 readers in total. So that's going to be our denominator. So this will be for the males. We'll go over here, and females. Again, the denominator is 35. Males made up 15 of those, and females made up 20 of those. So 15 out of 35 is 3/7. So that's got to be around 43%, I would think. Let's grab my calculator. 15 divided by 35, and 42,857. So this is 42.857%. So we should already know what the female readership is, because this is, and I'm reaching ahead into the probability discussion coming up. There are 35 people in total here. 15 are in one of two categories. The remaining 20 have to be in the other category, right? So you can always check your numbers by just thinking about, does this make sense? It should make sense. It doesn't necessarily mean everything works 100%. So here we have 20 out of 35, so that divides, that's 4/7. And Mr. Calculator says we have 57,143. Or 57.143%. So that plus that has to equal 100%. There we go. Oh, we got Kayla here. Okay. Yeah, it was a neat class, probability and statistics, permutations and combinations. Okay, so a little bit extra there. Different forms of distribution, bell curves, single and double variable statistics. Okay, double variable statistics. Now, that's kind of interesting. That sounds like a sort of a higher end calculus. Did you do any calculus in that course, by the way, Kayla, astronomy? Because if you're talking about a multivariable standard normal distribution, let me put up a new slide here. I don't know if I can draw this freehand or not. Let's do that. So the standard normal curve in the normal way of looking at it looks like this. But this can be turned into, if this is multivariable, this is single variable calculus to analyze that curve. So how can we do this without screwing this up? I used to be able to do this curve. So we need, yeah, here we go. So the point is, no matter what direction you come in, you have this pimple-like bump. Whoops, that should have went that away and that away. Yeah, so this should be, so these are level curves, right? If you're doing MV calculus. Ah, you did. Okay, cool. Where did you, I'm not trying to be overly nosy, but was this a college or a university in America or Europe or Canada? That's good enough for geolocation. I'm just curious where you studied that, because that's some mathematical horsepower attached to it. Ah, okay, cool. Right on. Yeah, so look at my level curves. My other lines here are kind of schizoid. Anyway, let's not even look at that abomination. Let's just go to the next slide. Cool. Okay, so this is a different table. We're going to do So if you're doing astronomy, I'm assuming that you've done a Bachelor of Science, or you're in a, I'm talking to Kayla Astronomy, by the way, on chat. I'm assuming that you've done a Bachelor of Science or are in progress with a Bachelor of Science. Is that a reasonable assessment? And if the answer is yes, have you completed it and how did you enjoy it? Because astronomy is kind of a cool topic. If I was a younger dude, I wouldn't mind studying more of that again. Ah, okay, right on. Well, I'm glad that you're enjoying it because lots of people go, ooh, math, but not you, and that's good. Um, I'm assuming you have good instructors. I know here at the University of Alberta, there's a we have light pollution for sky observing for observations of the night sky. Not as bad as some places mind, but when they rebuilt the science center, I know they did some very good work on redoing the observatory that was attached to the old science building. Um, Moving on here. So sometimes with contingency tables, we need to complete them. So the thing I want to point out now is if they give you a partially completed contingency table, the goal is to first fill out all the missing numbers. And that's simple arithmetic, maybe a little algebra. If we look at arts, the Faculty of Arts, we know that total enrollment is 35% of total enrollment. And females make up 16 percentage points. I didn't say percent, it's percentage points of that enrollment. So what number plus 0.16 equals 0.35? And it's got to be 0.19, so let's put that in there. So this, we'll just write that out, this is 0.19. Now, the thing to keep in mind is for any row or column like this where you have two of the three numbers, you can always find the missing number. Let's go to the sciences row. We have 18 percentage points out of a total of 40 percentage points. Okay, Kat, what are you doing over there? We have cats, by the way, and this one's trying to get herself unstuck from the screen. Are you stuck? Hey, dingus. I have to hook my cat camera up sometime. Yeah, you're stuck. Uh-huh. Ragdolls. They do ragdoll things. And anybody interested in having pictures of the ragdolls and the other cats on here sometime? Maybe I'll put them up for next lecture. I don't have that handy right now. Sciences, 18 percentage points plus some other number of percentage points equals 40 percentage points. Well, this must be 0.22 because 22 and 18 make 40. There we go. Now let's look at the totals column. Remember, the totals column always has to add up to 1.00, 100%. So here we have 35 and 40 for 75, so then this must be 0.25. That makes sense. And now we can actually get this number. I could have got it earlier too, mind, but this has got to be 0.1. And we should check everything. So 18 and 19 is 27, 37, pardon me, plus 10 is 47, so that adds up. This must be 53 percentage points. So there we go. We're good to go. So always check your tables, add them up. Okay. Now, oh, and there's Abigail. Abigail is a standard issue cat, but we call her the house panther because she looks like a panther and cops an attitude just like a panther, too. Where did you go? She'll be back. They always come back. Anyway, so a partially completed table needs to be completed before you can do anything else. If you want to answer questions, you got to get on and get doing that. So let's move on here to the next slide. So this, now that we have this completed, is just more of the same that we've already done, except here, instead of giving you frequencies or counts, we're given percentages. And basically we're going to do the same thing that we did before. What is the conditional relative frequency? So that's your decimals. Distribution of faculty for females. So conditional, remember, means inside the table. So here's the female column right here, the green. And the only thing that's really different now that we're going to do, like in the preceding table, we could have left the fractions and that would have been fine. But here, we really should simplify this. So here we have arts has 16 percentage points out of 53 percentage points. So this should probably, in the interests of clarity for the readership, should be reduced. So grabbing Mr. Calculator here, we have 0.16 divided by 0.53. That works out to just over 30%. 30189. So we can say 30.189%. We can do the same now for the other two faculties. Sciences. Here we have 0.22 out of the 0.53. Well, that's got to be close to 40%, I would think. Probably 0.22 divided by 0.53 is 4151. 0.4151 or 41.51%. And the other well, let's see here. If this is 41.5 and this is 30.2, we can say that right now this makes just under 72%. So if this is approximately 72 percentage points, approximately, that means whatever the other is better be really close to 0.28. Otherwise it doesn't make sense, or 28%. Let's check. Here is 0.15 and 0.53. So 0.15 divided by 0.53 is 28.3. 302%. So again, a little bit of eyeball work. You don't have to use a calculator. You can see if you're really on track or if you've made any mistakes. Okay. See, there's an ad running. I was wondering if there's time to go grab a cat picture, but probably not. Yeah. Nope, ads are almost done. Okay. And we're back, I think. Yeah, we are. Okay, cool. So you'll notice I also have the male column highlighted too. I was thinking we could work through these as well. So for the males, we have 0.19 over 0.53. We'll figure that out in a moment. Then I have 0.18. Now, why am I using 53? That's how mistakes happen. You put your brain on hold. The ad was running, and then I'm back here. It's not 53 anymore. It's 47, right? New denominator because we're in a new column. And 47, that's supposed to be a 4. And then we have 0.10 out of 0.47. So if we do all this, we will also get our percentages. So I'm going to do these all at one shot because, fancy schmancy calculators let you do that, he said with a great deal of confidence, having not done it before, but winging it because you only living once. Divided by 0.47, and it worked. Woohoo! Okay. Here we have, this is 40.423%. And then we have 38.298. And the 10 out of 47 is 21.277. And again, we'll do a sniff test on this. So here's 40 and 38, that's 78. And if we're just adding the integers, 78 This is already at 99%. So we're good. We're good. Okay, cool. Now, just a quick question here before I go to the next slide for Kayla Astronomy on the chat. I'm very curious if you've had opportunity at your school to do any observatory work, or has it just been mostly in-class sessions? I'd be very curious to know what your school offers for opportunities to get some sky observation time. And let's click the next button here. Okay, same table now, but now we're going to look, instead of columns, we're looking at rows. And again, we want the conditional by gender in the faculties. So now we're going to go across instead of up or down. So for instance, in the Faculty of Arts, there's a couple ways to think about this. There are 35 percentage points out of the total 100 percentage points in the Faculty of Arts. And the split is 19 and 16 respectively for male and female. If the use of decimals messes you up, one of the ways to think about this is think instead of 100, or instead of 1.00 or 100% down here, think of this as says there's 100 people. So if this is a total of 100 people, then we can say that 35 out of the 100 people are in the Faculty of Arts. And that means 16 of those 35 are female, and 19 of the 35 are male. So if the use of decimals is messing you up, just remember to think about it. This is out of every 100 people. Okay. Kayla says, first year, mostly classwork. Older students, then we'll get, good, good. Glad to hear it. So if you're first year, and you've already done some of the they're probably teaching the multivariable calculus as required. Okay. I'm just curious because if you were doing the multivariable normal distribution in X and Y, for instance, it's not terribly hard to do multiple or double integrals and partial derivatives. I'm just curious if they taught that mathematics in the astronomy class, or they taught that mathematics in a specific mathematics class. Very interested in that. Okay, so right now let's do the arts thing while Kayla's answering that question. So our denominator is going to be 0.35. So we have males and females. We have 0.35 here. 0.35 here, and we want to turn these into respective percentages so that we can interpret this properly. Because that's the problem with the way the data is presented right now. It's not entirely clear what that means. Like here we have 0.16, but that's out of 1.0, but we're interested just in the Faculty of Arts. So we need to convert these values into something a tad more meaningful. So here we have 0.19 divided by 0.35. That's 54,286. So 54% are male. That means about 46% should be female. We'll just quickly bang that in there and find out 0.16 divided by 0.35, and we get 45.7. And 1.4, so this is 45%. 46%, we're rounding properly. Good enough. So that's what we have to do with this stuff. Now, let's look at the sciences faculty. Again, we have males and we have females. Now, in sciences, we have this divided by this, 1/8 divided by 0.4, And then over here we have 0.22 divided by 0.44. Now why did I do 4/4? That's silly. Boop, 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 boop. There we go. I was just getting into the rhythm, I guess. Okay, so 18 out of 40 is the same as 9 out of 20, so this is 45%. Then this must be 55%. And yes, it is. .22 divided by, we're just going to check because I think I actually have a clue. Sometimes it's quite apparent that sometimes I don't when it comes to mental arithmetic. But this is correct. And then for other, we have 0.10 divided by 0.25. Well, that's easy enough because this is the same as 10 over 25. So this is 0.4. And then that was for males. And then over here we have for females 0.15 divided by 0.25. So the thing is, if we were to reduce these fractions, this is kind of how I do this. So we know these both end in 5, so they divide by 5. This is the same as saying 3/5, which of course is 0.6. And 0.6 and 0.4 make 100%, so we know we're correct. Or at least we haven't screwed up too bad anyway. Okay, let's move on. Here's a good question. Do gender and faculty appear to be dependent or independent? So that when we get into the probability section, we'll have a more formulaic way of computing this, but let's take a look at the school distribution first. So what is the population or school distribution? We'll write it as school distribution here. So the school distribution is 47% male, 53% female. And I'm getting that from this. Totals. The column totals. This tells me that there are 6 percentage points more females at this school than there are males. So if faculty and gender are independent, then we should have similar percentages for each of the faculties. If they're dependent, then they will be different. Now, we're not talking about exact matches here, so this is where you got to make a judgment call. Close. If the distribution of the faculty male-female split is close to 47 and 53, then there would be independence there. If they're different, they're dependent. Now, what qualifies as different? Well, I'm going to go and say anything within 3 percentage points or more is different. And that's a judgment call on my part. And if you have to do a thing like this, it'll be a judgment call on your part, because you're very unlikely to get exact. So let's look at arts. There are 35 percentage points. So this is where it helps to stop thinking about this in terms of percentage and think about this in terms of per 100. So in the Faculty of Arts, there are 35 students, of which 19 are male and 16 are female. So let's find out how close arts matches the population distribution. So here we have 0.19. So yes, I'm going to go back to using the decimals, but you can do it without the decimals if you want. And over here we have 0.16 out of 0.35. Let's see what those numbers actually are. And I get them, that divided by that is, this is, whoops. Okay, we'll use the decimal instead of trying to write that out. 5.4, I'm just going to use 1 decimal 3. So this is 54.3%. So this is higher than the school distribution. And again, I said I'm using the cutoff of 3 percentage points. So that would suggest that there is a dependency in arts. Let's see what the other one is. 16 divided by 35. Yes, I could have gone 1 minus, but I'm lazy. So this is 0.457. So here we have 45.7%. So you'll notice these are reversed. The school distribution is 47 to 53. The arts faculty's distribution is 54 to 46. So right there we can say, yes, they appear to be dependent just by that one blip, that one faculty. 'Cause remember, for a counterexample, you only need one exception. Oftentimes you hear somebody muttering, oh, but exceptions, the exception proves the rule. Whenever you hear someone say that, I want you to reach across the table and cuff them with your back of your hand. Because if you're going to repeat an old saying, try to get it right. Exceptions disprove the rules. That's a pet peeve of mine, by the way, that misinterpretation of that saying. Smack! Smack! All right. Sorry, getting hyper there. Let's look at sciences. We look at the faculty of science. Well, we need to check males versus females. So here we have 0.18 divided by 0.4. And here we have 0.22 divided by 0.4. Now let's see what these translate into. 0.18 divided by 0.4 is 45%. I'm just going to write it as percent this time. And that should mean that 55% is over here, right? Well, 47 to 53, here's 45 to 55. I would say this is independent because it matches the school distribution. There's no dependency in sciences. So this one here is different than the result we had here. Now, what about the last part? The 10 and the 15. Well, we already looked at that earlier. This is 0.4 versus 0.6 for males and females. And yeah, this would be probably, well, using my personal cutoff, this would also be dependent. But at least it matches the trend where in this school there are more female students than there are males, and we see the same trend in the faculties under the category other. So as with much in statistics, you have to make a judgment call on these things, and that's what we've done here. To summarize, the arts faculty has definitely got a dependency because the relationship of males and females in that faculty is quite different from the distribution of males and females overall in the school. Whereas that's not the case when we looked at sciences, and it again is the case when we look at other faculty categories, although the magnitude of the differences is somewhat larger. So there we go. That is an exam question. And I am done my slides here. That's it. So did this thing go for an hour? Yeah, we did about an hour again today. That's pretty cool. All right, so I'm just going to say for next lecture, it's time we started talking about probability. And we're going to spend several lectures on this topic. Probability and See, I can't spell this word to save my life. And you'd think, I knew there we go. Okay. Next time, probability, where we take our life in our hands. Okay. I have yard work to do. Woohoo! Tons of it, I might add. And that also involves moving stuff. And I'm old, so I'll be limping around, but you won't see it. You guys, thank you for joining me today. Hope this added a bit more understanding to the business of contingency tables, which were not free and clear of. We're going to have contingency tables in context to probability coming up as well. So, yeah, you're going to be experts in this by the time we're done. In the meantime and in between time, have a great day, everybody. Thank you for joining us. And I think tomorrow on our next stream will be history of mathematics. I believe Adrian has done his adulting and is probably keen on doing some more historical stuff, or we're just going to kick back and play some video games. Anyway, keep an eye out for the next appearance of the Tutor Wizards. We'll be here. Hope you'll join us too. Bye bye.